Hello everyone. In this video, I'll explain about Laplace transform. Suppose you have a real valued function. F of t is a real valued function and it is an integrable function. Then for all t greater than or equal to 0, Laplace transform of f of t is defined as integral from 0 to infinity e power minus st into f of t into dt. This is the definition of a Laplace transform. You have a real valued function and it is an integrable function. Then for all t greater than or equal to 0, it is an improper integral from 0 to infinity e power minus st f of t into dt, where s is a parameter. And after simplifying all this, you will get a function of s. That's why the name transform. It transforms a function in a variable t to a function in a variable s. It is nothing but t means it transforms from time domain, one domain, t domain to s domain, time domain to usually a frequency domain. So Laplace transform is mainly used to solve differential equations. The differential equations which are not solvable in t domain will be converted to s domain. Then that equation is solved there. Then using the inverse Laplace transform, the solution is converted to time domain back. That is how we use Laplace transform. Some of the problems which are not easy to solve in one domain will be converted to some other domain. Then there it is solved. Later it is transferred to the previous domain using the inverse Laplace transforms. So this is the definition of Laplace transform, and whatever answer you will get, it is a function of s. Here input is a function of t, output is a function of s. This you have to remember. And Laplace transform is a linear transform. That means it satisfies the property of linearity. Laplace transform of C1 F1 of t plus C2 F2 of t can also be written as C1 constant can be taken outside into Laplace transform of F1 of t plus C2 into Laplace transform of F2 of t. This property is called as linearity property of the Laplace transform. Laplace transform is linear. That is because integral is linear transform. As Laplace transform uses the integral in its definition, therefore it also satisfies the linearity. Now see here the first problem. Find the Laplace transform of this function. This is solved using the definition of Laplace transform. The definition of Laplace transform is integral from 0 to infinity e power minus st into f of t into dt. Now the function has two different values. From 0 to 4 it is having the value t. From 4 to all other values t greater than 4 function is 5. So integral here it is 0 to infinity. Now you have to split the integral. 0 to 4 e power minus st. What is the function from 0 to 4? It is t into dt plus integral from 4 to infinity. For all other values greater than 4, the function is 5 into dt. You have to integrate this now. So this is equal to integration by parts. So integration by parts can be solved using Bernoulli's generalized rule for integration by parts. That is, if you have integral of uv with respect to t, then u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4 plus so on, where all these v1, v2 are integrals and u dash, u double dash, they are derivatives. So uv dt is u into v1 means first integral of v dt. v2 means integral of v1. Then v3 means integral of v2, like that. So alternative positive and negative sign. So that helps you to simplify the work quickly. See, now this is u, this is v. How to choose u and v? Using Eilert rule. That is, this rule: inverse, logarithmic, algebraic, trigonometric and exponential. Exponential is always chosen last, that is always second function. So u is the first function, is it, here it is algebraic, u into v. So as per the rule, t into, what is integral of e power minus st? E power minus st divided by minus s, then minus u dash, derivative of t is 1 into v2. Now integral of this, integral of e power minus st by minus s is e power minus st divided by 1 minus s, already you have, another into minus st, you will get minus of minus plus s square you will get, then plus u double dash, what is derivative of 1? It is 0. So 0 into any value, it is 0. So it is from here 0 to 4. Then plus 5 is a constant you can take outside. Integral of e power minus st is e power minus st by minus s from 4 to infinity. Now you have to apply the limit. Now to apply the limit, see here, first 0 to 4, here you will get minus 4 by s, because this minus 4 by s into e power minus 4s, put t equal to 4, upper limit, minus lower limit is 0 into any value, it is 0. Next minus, here again upper limit t value is 4, so you will get e power minus 4s by s square, then lower limit is minus this bracket minus e power 0, it is e power 0 is 1, so which gives you 1 by s square minus 5 by s, this minus I have written here, minus 5 by s into e power minus infinity. So e to the power minus infinity is nothing but this 1 by e to the power infinity. E power infinity is infinity, 1 by infinity is 0. So upper limit you will get 0, minus lower limit is e power minus 4s. Replace t by this value 4. You have to simplify this now. So I will write here, after simplification you will get here minus 4 e power minus 4s by s minus e power minus 4s by s square, minus of minus plus 1 by s square, minus of minus plus 5 e power minus 4s by s. Okay, you can simplify this further as e power minus 4s by s minus e power minus 4s by s square plus 1 by s square. This is the final answer. Now let us see Laplace transform of some standard functions. So Laplace transform of any constant equal to a by s. That is directly using the definition of Laplace transform. Laplace transform of a is 0 to infinity e power minus st into f of t is a into dt. Take a outside. Then e power minus st integral is minus st by minus s from 0 to infinity. This gives you minus a by s into upper limit is e to the power minus infinity 1 by e power infinity. 1 by infinity is 0, minus lower limit is e power 0 is 1. So that gives you a by s. So Laplace transform of a is a by s, where a is any constant. A is any constant. Next, Laplace transform of e to the power at is 1 by s minus a. This is a function in the t domain. After taking the transform, it gives you a function in the s domain as 1 by s minus a. So here also you have to apply the definition, which is 0 to infinity e power minus st into e power at into dt. So simplify, this is 0 to infinity e power at minus st. So t into a minus s into dt. So apply the integral here. E to the power a minus s into t divided by a minus s. Integral is from 0 to infinity. You can simplify this as e power, take minus common, s minus a divided by a minus s from 0 to infinity. I have done this because while applying the limit it is easier to simplify. So this gives you, I will write here, e to the power into t here. So apply upper limit. E to the power minus infinity is 1 by e to the power infinity, which is 1 by infinity, that is 0. So you will have 1 by a minus s into 0 minus e to the power 0 is 1. So this gives you 1 by s minus a. So in Laplace transform of e power at is 1 by s minus a. Laplace transform of e power minus at equal to 1 by s plus a. You can check with that. Replace a by minus a, so that becomes 1 by s plus a. Next, Laplace transform of sine hyperbolic t. Sine hyperbolic at. So this is equal to, we can write sine hyperbolic at as e power at minus e power minus at divided by 2. This is the definition of sine hyperbolic function in terms of exponential function. 1 by 2 you can take it outside. Laplace transform is a linear property. So then Laplace transform of e power at, just now we got 1 by s minus a minus 1 by s plus a. Let us simplify this. 1 by 2 into s plus a minus s plus a by s minus a into s plus a, that is s square minus a square. So this is equal to 1 by 2 into minus s plus s cancels 2a by s square minus a square. So that gives you 2 cancels a by s square minus a square. So this is Laplace transform of sine hyperbolic of at. Similarly, Laplace transform of cos hyperbolic of at is equal to, it is s divided by s square minus a square. You can check this. Same here, instead of minus you have plus for cos hyperbolic at. E power at plus e power minus at divided by 2. Next is Laplace transform of sine at. So this is given by a by s square plus a square. Okay. This is proved using the definition of Laplace transform sine at equal to e power 0 to infinity minus st into sine at into dt. Now to evaluate this integral, you have to make use of this formula. Integral of e power at sine bt with respect to t is e power at divided by a square plus b square into a sine bt minus b cos bt. This is the formula. So apply the formula here and get the required transform. That is e power minus st divided by a square plus b square. A is minus s whole square plus b is a square into a sin bt minus s sin at minus b cos bt. A cos at. Integral is from 0 to infinity. You have to apply the integral now. 1 by a square plus a square is common, constant, you can take it outside. E power minus infinity, that gives you 0, upper limit is 0, minus lower limit is sin of a into t is there. Sin 0, 0, upper limit is for this term, upper limit as well as lower limit both 0. Now for this term minus a is a constant, e power minus st. So upper limit is e power minus infinity, which is 0, minus lower limit is e power 0, 1. Cos of 0 is also 1. So this gives you a divided by a square plus s square. So that is the required answer. Next one, Laplace transform of cos at, which is s by a square plus a square. Now this is evaluated using the formula e power at cos bt dt is e power at divided by a square plus b square into a cos bt plus b sin bt. So using that formula, you can evaluate the integral. You check with that, same as the previous case. Next is Laplace transform of t to the power n. It is given as n factorial by s to the power n plus 1. When n is positive integer, then only this is valid. So that is because Laplace transform of t to the power n, as per the definition, 0 to infinity e power minus st into t power n into dt. Now if you apply the integration by parts rule, then you will get t to the power n into e to the power minus st divided by minus s minus integral of this. Integral of e power minus st divided by minus s into derivative of t to the power n into t to the power n minus 1 into dt. So this gives you now, so the limit is 0 to infinity. Anyway, this value is 0. Okay. Minus, you will get minus of minus plus 1 by s into integral of e power minus st. N is constant outside, t to the power n minus 1 into dt. Therefore, Laplace transform of t to the power n, you will get it as n by s into, this is nothing but Laplace transform of t to the power n minus 1 as per the definition. The e to the power minus s t to the power n is nothing but Laplace transform of t to the power n. Now in the place of t to the power n, you have t to the power n minus 1. So it is Laplace transform of t to the power n minus 1. So if you continue like this, then Laplace transform of t to the power n by s into n minus 1 by s into Laplace transform t to the power n minus 2. Similarly, n minus 2 by s into, and so on. You have to continue like this, and so on up to 1 by s into, finally remaining is Laplace transform of t to the power 0, that is nothing but t to the power 0 is 1. So here you have n into n minus 1 into n minus 2, as it is positive integer, you will get it as n factorial divided by s here n times into Laplace transform of 1 by s it is. So you will have s to the power n plus 1. So therefore, when you have n as a positive integer, Laplace transform of t to power n is given as n factorial by s power n plus 1. Next, generalization for Laplace transform of t power n. Earlier was only when n was positive integer. Now here, when n is any positive real or n is negative non-integer. Negative integer, that is not correct. Negative non-integer. For all negative non-integers, we have this formula. It is given by gamma of n plus 1 by s to the power n plus 1, where gamma is a gamma function. So that is 0 to infinity e power minus st. We had t to the power n into dt. Then this can be simplified as 0 to infinity. You have to take st as x. It has a new variable. Put st equal to x, dt equal to dx by s. Then accordingly, x is also from 0 to infinity. So e power minus x into t is x by s to the power n into dx by s. So that is equal to 1 by s to the power n plus 1 is a constant. 0 to infinity e power minus x into x to the power n into dx. This is the definition of a gamma of n plus 1. So gamma of n plus 1 divided by s to the power n plus 1. So when n is a positive real or n is negative non-integer, in that case the Laplace transform of t to the power n is given as this. Okay. Even n is positive integer also, you can write like this, because gamma of n plus 1 equal to n factorial. When n is positive integer, gamma of n plus 1 is n factorial. So you can replace that by n factorial by s power n plus 1 when n is a positive integer. So we have a list of Laplace transform of standard function. Laplace transform of a constant a by s, e power at 1 by s minus a power minus at 1 by s plus a, sin at a by s square plus a square, cos at s by s square plus a square, sin hyperbolic at a by s square minus a square, cos hyperbolic at s by s square minus a square, and Laplace transform of t to the power n is gamma of n plus 1 by s power n plus 1. When n is positive integer, gamma of n plus 1 becomes n factorial. Now let us take some examples. Laplace transform of 1. Find Laplace transform of 1. 1 by s as per this formula. Then Laplace transform of e power minus t. So this is equal to 1 by s minus of minus plus e power minus a t is 1 by s plus a. What is the value of here? A equal to 1. Okay, e power minus 80. Don't take a as minus 1. Even if you take a as minus 1, then you apply this formula. 1 by s of minus 1 becomes plus 1. So here now a equal to 1. So e power minus 80 means 1 by s plus 1. Next, Laplace transform of 3 into e to the power 40. 3 is a constant, you can take outside. Then Laplace transform of e power 40. That is this formula. A is 4 now. 1 by s minus 4. Okay. So next, Laplace transform of 3 sin hyperbolic 2t. So this 3 is a constant. Sin hyperbolic 80. A is now 2. So 2 divided by s square minus a square is 4. So 3 2s are 6 by s square minus 4. This is the answer. Next, fifth one, Laplace transform of t to the power 5. Now 5 is a positive integer. So gamma of n plus 1 becomes n factorial. So 5 factorial divided by s power 6, 120 by s to the power 6. Next question. Laplace transform of, here you have to find root of t. So it is Laplace transform of t to the power half, correct? No. This is a positive real number, it is. So gamma of, I want 1 by 2 plus 1, this divided by s to the power 1 by 2 plus 1. I have to simplify this. See, gamma of n plus 1, gamma function has a property n into gamma of n. So here now n is half, so half into gamma of half, it is, n is half, divided by s to the power 3 by 2. So you should remember the value of gamma of half as root pi. So this becomes root pi by 2 now. Gamma of half is root pi by 2. So I will write here final answer root pi by 2 into s to the power 3 by 2. This is the answer for Laplace transform of square root of t. So these properties you have to remember. And gamma of half value is square root of pi. Next is Laplace transform of 4 into t cubed. 4 is a constant. You can take outside t cube. So n is a positive integer here. So 3 factorial divided by, because this is equal to n factorial by s power n plus 1 when n is positive integer. So s to the power 4. 3 factorial is 6. So you will get 24 divided by s to the power 4. Next, Laplace transform of 3 cos 4t. 3 is a constant. Take it outside. Cos 4t. So what is Laplace transform of cos 80? S by s square plus a square. So s divided by s square plus a is 4. 4 square is 16. So this is 3s by s square plus 16. Next one, Laplace transform of sin 5t into cos 2t. So here you don't have direct formula for sin at into cos bt. You have to make use of trigonometric identities here, product rule, product formulae. So that is sin x into cos y equal to 1 by 2 into sin of x plus y plus sin of x minus y. This formula you have to use here before applying the Laplace transform. So it is 1 by 2 into sin of 5t plus 2t is 7t plus sin of 5t minus 2t is 3t. Let us simplify this. 1 by 2 into Laplace transform of sin 7t. So it is this formula, 7 divided by s square plus 7 square is 49 plus here 3 divided by s square plus 3 square is 9. So this is the required answer. Next is Laplace transform of 5 to the power t. See, you don't have the direct standard formula for Laplace transform of 5 power t, but I can write this as Laplace transform of e to the power log of 5 to the power t. Okay, because exponential log cancels. Log means natural logarithm. You can write ln also. E power log of 5 to the power t. So this is Laplace transform of e to the power log of 5 into t. Log of a power m is m into log a. So power can be written as a product here. T into log of 5. So you will get t into log of 5. So now you have to make use of Laplace transform of e power at formula. So this is equal to 1 by s minus what you have in the place of a now, a into t. So that is log 5. So this is the required answer. So when it is not in this form, direct standard form, you have to convert it into the standard form, then apply the formula. Now one more, Laplace transform of e power minus 2t into sin hyperbolic 4t. So this can be simplified as e power minus 2t, not directly available as a standard function. Sin hyperbolic 4t, we have the definition, minus e power minus 4t by 2. So 2 is a constant. So 1 by 2 is a constant. Take it outside. Now simplify this. E power minus 2t plus 4t. E power 2t minus e to the power minus 60. So this is 1 by 2 into 1 by s minus 2 minus 1 by s plus 6. So when you simplify this, you will get s minus 2 into s plus 6 here. Then s plus 6 minus s plus 2 cancels 8 by s minus 2 into s plus 6 into 2 here. You have 2 ones, 2 fours. So this is 4 by s minus 2 into s plus 6. This is how we calculate the Laplace transform using the standard functions. See now the last question. You have to find Laplace transform of t power 5 by 2 plus t power minus 5 by 2. Split it as Laplace transform of t power 5 by 2 and Laplace transform of t power minus 5 by 2. Okay, now we have to find out individually. So what is Laplace transform of t to the power 5 by 2, which is gamma of 5 by 2 plus 1 divided by s to the power 5 by 2 plus 1. This is using the formula Laplace transform of t power n equal to gamma of n plus 1 divided by s power n plus 1. Okay, here n is 5 by 2. Now let us simplify this. Gamma of 5 by 2 plus 1, which is equal to, as per the formula, if n is positive, this is the value of gamma of n plus 1. If n is negative, this is the value of gamma n. These two things you have to remember. Here n is positive now. So this is 5 by 2 into gamma of 5 by 2. This is equal to, now this is equal to 5 by 2 into gamma of 5 by 2 can be written as 3 by 2 plus 1. So that gives you 5 by 2 into, again apply the same property, 3 by 2 into gamma of 3 by 2, which is equal to 3 by 2 is written as 1 by 2 plus 1. So 5 by 2 into 3 by 2 into 1 by 2 into gamma of 1 by 2. Now gamma of 1 by 2 can be simplified as a value is root pi. So 5 3 is 15 by 8. So finally the answer is 15 by 8 into square root of pi. This is the value of gamma of pi by 2 plus 1. Therefore we will get the Laplace transform of t power 5 by 2 is 15 root pi divided by 8 into this s to the power 7 by 2. Plus, let us find out Laplace transform of this. The Laplace transform of t to the power minus 5 by 2. As per this formula, it is gamma of minus 5 by 2 plus 1 divided by s to the power minus 5 by 2 plus 1. See, gamma of can be written like this, or we can write it like this also, gamma of n plus 1. Anything is fine. So let us find out gamma of this, gamma of minus 5 by 2 plus 1. So this is equal to, after simplification you'll get gamma of minus 3 by 2, because when n is negative we have to use of gamma n property. Gamma n is, this is equal to gamma of minus 3 by 2 plus 1 divided by minus 3 by 2. Okay, as per this property, gamma of n equal to gamma of n plus 1 by n when n is less than 0. It is less than 0 now, n is negative. So this gives you, this is equal to gamma of minus 3 by 2 plus 1 is nothing but gamma of minus half divided by minus 3 by 2. So this is minus 3 by 2. Now once again, what is the value of gamma of minus half, which is, as per this, gamma of minus half plus 1 divided by minus half, and already you have this minus 3 by 2 here. So after simplifying, I'll write here, it is equal to, here you will get gamma of half divided by minus 3 by 2 minus 1 by 2, that is 3 by 4. What is the value of gamma of half? Root pi, 4 pi by 3, 4 root pi by 3. Hence, you will get Laplace transform of t power minus pi by 2 as 4 root pi divided by 3 into here s to the power minus 3 by 2. This is the required answer. So, you have to remember the property of the gamma function. When n is positive, gamma of n plus 1 as n into gamma of n. And when n is negative, gamma of n is gamma of n plus 1 divided by n. when n is negative. And negative means divided by, positive means into here. I hope you understood.